Have you ever thought about how every drop of water on Earth moves, from the clouds to the oceans and everything in between? It is a fascinating and complex journey. Understanding this continuous movement, and keeping track of it, is fundamental to managing our most vital resource. Hydrologists use a powerful tool to make sense of this intricate system, ensuring we can predict and plan for water availability. In water balance, inflow and outflow are accounted for by using a simple yet profound mass balance equation. This equation states that the total amount of water entering a defined system, minus the total amount of water leaving that system, must equal the change in the amount of water stored within the system over a specific period. It is essentially an accounting ledger for water, allowing scientists to quantify its movement through any given area, whether that is a small pond or an entire continent. The core mechanism behind this accounting is the principle of conservation of mass. Just like you cannot create or destroy money in a bank account, water cannot be created or destroyed within a hydrological system. It can only change its form or location. Inflows typically include precipitation, such as rain and snow, along with surface water flowing into the area from upstream and groundwater flowing in from adjacent aquifers. Outflows consist of evapotranspiration, which is the combined process of water evaporating from surfaces and transpiring from plants, plus surface water leaving downstream and groundwater flowing out. Human activities, like water withdrawals for agriculture or urban use, are also crucial components of both inflow and outflow, often categorized separately. Applying this in practice involves defining a specific geographic area, known as a control volume or watershed, and then measuring or estimating all water components over a set timeframe. For instance, to calculate the water balance for a lake, you would measure precipitation directly over the lake, inflow from rivers and streams, and groundwater seepage into the lake. Simultaneously, you would measure or estimate evaporation from the lake's surface, outflow through its outlet river, and groundwater seepage out of the lake. The difference between all these measured inflows and outflows reveals whether the lake's water level is rising, falling, or remaining stable. This detailed accounting provides a critical hydrologic budget for any given region. One insider detail is that accurately measuring evapotranspiration, especially from large vegetated areas, is often the most challenging component to quantify, requiring advanced remote sensing techniques or complex hydrological models. Another key insight is that even small, consistent imbalances between inflow and outflow, if sustained over long periods, can lead to significant environmental changes, such as aquifer depletion or persistent flooding. These budgets are vital for sustainable water resource management, flood forecasting, and understanding the impacts of climate change on regional water availability. Ultimately, by meticulously accounting for every bit of inflow and outflow, the water balance equation provides a powerful framework for understanding and predicting the dynamics of water within any system. This knowledge allows us to make informed decisions about managing our freshwater resources, protecting ecosystems, and ensuring water security for communities across the globe, contributing significantly to a sustainable future.
If you love learning about water, like, subscribe, and keep exploring with us.